Greetings, Math 2015 students. I hope that you're all having a great day so far. We're going to take this day of class to do some similar homework examples and then do a little prep for next class of Learning Outcome 2. So today is Math 2015. We're going to do Learning Outcome 1, and then it's going to be day 2. Okay, so first we're going to do similar homework examples and go over some homework examples. We'll just call that homework examples. That's part 1 for today. We want you to know kind of how to respond to these homework questions. Definitely do the reading, definitely go through the relational and computational views of the equal sign. But I'm going to go ahead and expound a little bit more on the what saying true or false, whether these equations are equal, okay? Whether the equal sign is used properly. So my first example is going to be 1492 is equal to 1492. That's what they propose. Okay, so we want to use a question mark above our equal sign as we are asking if that is true. Okay, so is 1492 equal to 1492? It seems a little bit trivial, but as you saw in the video from the PowerPoint for this learning example, learning outcome number 1, that the students get a little bit confused about that. And so we're going to say that it is true, of course, because, and this is what you need to do on your homework, say why it is true. Okay. And this one is actually, because it is a little bit trivial, the answer is also a little bit trivial. It's true because 1492 is the same as 1492. Okay, let's do example number 2. We're going to say that take a look at this property here, this equation. 25 plus 13 is equal to 23 plus 11. Okay, we need to weigh the different sides of the equation, look at it relationally, and decide whether those are true. Okay, is that equal? It actually turns out that it's false. But the key is to put in the reason, because. Okay, we want to do because for everything. Because that's what our students will want to know. Okay. Notice, let's take a look at the both sides. When you're doing this analysis with the equations, you have to look at both sides or all sides of the equal sign and make sure that they're all true. Okay. How can we compare the numbers? Well, 25 and 23 are about the same. Okay. What's their difference? Well, 23 is 2 less than 25. Okay, or 25 is 2 more than 23. So we have 23 plus 2 on that side. We can substitute that that expression in for 25. And the 13, notice that the 13 is 2 more than 11. Which is going to be 11 plus 2. Okay. Is that still equal to 23 plus 11? Okay, we're going to just do it step by step here. Notice that on this side here, we have 23 and 2, we have 11 and 2. So those are both quantities that are more, 23 and 23, 11 and 11. Both these quantities on this side of the equation, the 25 and 13, are 2 more than both of the quantities on the right side of the equation. Okay. Therefore, we can say it is false, okay, because both quantities on the left side are 2 more than both quantities on the right side of the equation. Okay, so that's why that is not true. They are not equal. Okay, so my third example is going to be kind of a tricky one. Let's go to number 3 here. And we're going to see if this is equal. So we have 7/10 divided by 2/5. Is that the same as 7/10 times 5/2? Okay. Are those quantities the same? Well, we need to make arguments for both. So remember, you take both sides of the equation here, okay, and look at them. We can work comparing each other, or we can kind of simplify one side of the equation to look like the other. Now, when you take 7/10 and you divide by 2/5, what do we have? If we take our 2/5 and we change it into 4/10, okay, we can compare the tenths together. So 7/10 divided by 4/10, which means how many groups of 4/10 can I take out? Can I divide the 7/10 into? Okay. So 7/10 divided by 4/10, I can take out one group of 4/10, and after I take out one group of 4/10, I have 3/10 left over. Okay. So if I have 3/10 out of the 4/10, which is my group size, I have 1 3/4. That one. Okay, so this part right here, this side can simplify to this step and then to this step. Let's take a look at the other side. 7/10 times 5/2. Okay, so we can go ahead and multiply the numerators and denominators. We get 35 over 20. Okay, and we can simplify that by dividing each one by 5. And 35 divided by 5 is 7. 20 divided by 5 is 4. And we can set that equal to 7/4. Make it like this one over here on the left side. 7/4 is indeed equal to 1 3/4. Okay. So this side has been transformed into this one, and this one, and this one. So notice that these are the same. Okay. So the answer is true because both sides of the equation can be operated, manipulated, I like operated, I guess, better, on to become the same quantity, the same number. Okay, so that's another reason why you can show equality for the equal sign, so they are true. Okay. So this one is going to be a check mark. This one up here is a check mark, but this one up here is not true. Okay. All right, let's go into another one. Let's do a similar one right here as to number 2. We're going to do 11 plus 44 is equal to 42 plus 13. Okay, so let's take a look and do another analysis with each of the sides of the equal sign. So we have 11 and 44, we have 42 and 13. we can compare each of the quantities. Now, 11 is close to 13. So we're going to do that here. We're going to say, okay, well, 13 is the same as 11 plus 2. Change that there. And 42 and 44. 42 is the same. No, 44 is the same as 42 plus 2. Okay. So I'm going to say addition. You can do subtraction if you want to as well. And then 11. So that's my 42 and my 13. So these ones right here, since I've added 2, and I have my 42 here, and I have my 11 here, we can compare those quantities to the other sides of the equation. And we have 11 we can just bring down, and then we have our 42 we can just bring down. Okay, so notice that those ones are the same here. So 42 are the same, 11 and 11 are the same. And the only difference is this 2 here and then this 2 here. Now, since they are both being added to the opposite sides of the equation, they will maintain a balance. Okay? And so, since it's true that these are equal, because 13 at the end, 13 is 2 more. Is 2 more than 11. Okay, they're on opposite equal signs, opposite sides of the equal sign, and so that means they're balanced. They have that. Well, 13 is at the right side, so it's got 2 more than the 11 on the left side. Okay, so we got to make sure we keep track of that. And 44 is 2 more than 42. Okay. Now 44 is on the left side and 42 is on the right side, so they've both been balanced here. So we can say therefore they're balanced. The equation is balanced. Okay. And we'll talk more about that learning outcome too, about keeping the equations balanced as we work on them. Okay, so the equation is balanced, and that means that is true. Okay, think of it as a pan balance. Okay, where one side has weights on it and the other side has weights on it, and they're balanced. Okay. All right, our last example for homeworks is this type of thing that people like to do in mathematics. Okay, I'm going to think about the operations of 36 divided by 9 times 7. Okay, I'm going to say that is equal to, well, I'm going to take the 36 divided by 9 first, right, because of the order of operations. That's going to be equal to 4, and I'm going to say, well, then I'm going to take by 4 times 7 now, and I'm going to set that equal to 28. Okay, so I'm done. Right, so I've checked that. 36 divided by 9 times 7, 28. Now, since I've written it in this way, is it true that this side, right here, is equal to this one? Is it true that this one is equal to this one? Is it true that this one is equal to this one? And finally, is it true that this one is equal to this one? All those parts need to be the same because equal sign means the same as. Okay. Well, we know that when we take a look at this one right here, and that is not the same as this one because they have the times 7 here, but no times 7 over here. Okay. So even though these first parts are the same, 36 divided by 9, this one says I need to multiply by 7, and that one I'm not. Okay, this one I'm not, this one I am multiplying by 7. Because automatically they cannot be the same quantity. Now 36 divided by 9 is equal to 4, so this one's technically equal to that one. Okay, but I don't have that. This 4 is equal to this whole thing here. Okay, so because that's true, then I'm violating the equal sign from this part of the equation and this part of the equation. 4 is also not equal to 4 times 7, but 4 times 7 is equal to 28. Okay, so we have those there. All right, so we have some parts where they're not equal for sure, but these parts are equal, and that's not equal, but these parts are equal. And because of that, we have inequalities here, and amongst the equalities, we cannot say that the equations are equal. Okay, so that's going to be false, because not all parts of the equation, the long equation, are equal to each other. Okay, so they need to be all equal to each other if you want to make this equation and not violate the symbol, the use of the symbol of the equation. Okay, so all right, so there's a couple of explanations for some of the homework problems, and that will help you get started on that.